Now let's try and use the rules to name some compounds, some binary compounds. Here we have Ki, potassium and iodine forming a compound. When you go on the periodic table, you are going to see that potassium has atomic number 19. That means when you want to share electrons, the first shell is going to take 2, the next shell is going to take 8. That will give us 10. That means we have 9 more electrons to share. The third shell is going to take 8. That means we have 1 more electron, and then the last shell will take 1. This means potassium is a group 1 element and therefore has oxidation number of +1. Now, this is very important because we will need this so that we can be sure whether to calculate the oxidation number or not. Now, we know that potassium is a group 1 element, so there is no need to calculate. Group 1 elements have oxidation numbers of +1. Now, we can go ahead and do the naming. K stands for potassium. Forgive my writing. And then the next element is iodine. Remember, we are going to replace the last 2 or last 3 elements with the suffix DE or IED. So here we are going to get iodide instead of iodine. So the first element, Ki, is potassium iodide. Now let's look at the second question. The second question is CO2. Carbon has atomic number 6. So if you want to share electrons, the first shell is going to take 2, the second shell is going to take 4. So that means carbon is in group 4. Group 4 elements have varying oxidation states. Therefore, we would need to calculate the oxidation number of carbon. Now we have 2 oxygen atoms, and this is a neutral compound, so everything should be equal to 0. Oxidation number of carbon, we don't know, so we use X to represent that. Oxidation number of oxygen is -2. How many oxygen atoms are there? There are 2 of them. So 2 times -2 will give us -4. Okay. Now, X plus -4 should be equal to 0. That is because CO2 is a neutral compound. Now, when a plus and a minus meet, it is going to change to a minus. So X minus 4 is equal to 0. We send -4 across the equal sign, and then we're going to have X is equal to +4. Therefore, the oxidation number of carbon over here is +4. So this is how the naming is going to be. Carbon into brackets 4 in Roman numerals is written as IV. And then instead of writing oxygen, we are going to take, or we are going to replace the last 2 or 3 letters with oxide. So we are going to have carbon 4 oxide as our answer. Now let me take the third one, and then we move on. Here, we know carbon is a group 4 element. Therefore, we need to calculate the oxidation state of carbon. But oxygen is -2. So oxygen is equal to -2. How many atoms of oxygen? 1. And therefore, the total charge on oxygen is -2. Carbon, we do not know. Everything should be equal to 0 because there is no charge. So X plus -2 is equal to 0. X minus 2 is equal to 0. You send -2 across the equal sign, and then you're going to have X is equal to +2. Therefore, this is going to be carbon to oxide. So one element, carbon, has varying oxidation states. Here it has 4, and then here it has 2. This is how we name binary compounds. First name comes if it is an element that shows varying oxidation states. You are going to calculate, and then after that you put the oxidation state in brackets, and then you write the name of the second element ending in IDE.